So, all right, a few more words about the conditional. The way that we actually generate the conditional, truth table for the conditional, is that whenever the propositional variable on the left-hand side has a false truth value, we say that the whole conditional is true. So, if I want to write out the table, if I want to generate the table for the conditional, then I look and see where P is false. That's the antecedent. It's what comes before. You can think about the Latin word ante is before. And then Q is the consequent. That's the thing that comes after the arrow. So in order to determine the truth value of the conditional, I look for when the antecedent is false. That tells me that the conditional in those cases is true. So I filled in half of the chart that way. And then when the consequent is true, then the conditional is true. You can check the truth table from the last episode. That's generally the way to fill in the truth table, is if the antecedent is false, or if the consequent is true, then the whole thing is true. And then the only case where it's ever false is when you have true false. And so an important note about this is that unlike conjunction and disjunction, which are commutative, you can just flip it. P and Q is the same thing as Q and P. Same story with disjunction. Not the story with the conditional. If you flip them around, then you definitely don't get the same truth table, and you can write that out. But you can just think of this one case, the case where it's false here. That's also the case where P is true and Q is false. So now imagine flipping the P and the Q, so that you have Q over here and P over here. Well, since you have Q on the left, you'd have false here, so you get a true truth value. So you flip them and you get something different. Now there's the last truth functional connective, which is called the biconditional, or if and only if. That's what I've written to the right. And that gives you the true truth value whenever they share the same truth value. So at the top they're both true, and so it gets the value true. At the bottom they're both false, so it gives you the value true. And in the middle they don't share the same truth value, and so you get false. So essentially what the biconditional expresses is truth value equivalence, that they have the same truth values in all of the possible worlds. So that exhausts all of the standard truth functional connectives. There are more, but they're almost never used. And there are other symbols that often represent the truth truth functional connectives. There's a lot of them. Polish notation is markedly different, so if you want to look at the different symbols that are used, you can look on Wikipedia or Google. But that's all that is immediately important about that. So we'll stop talking about truth functional connectives, and you should play around with them and draw out truth tables and get as much practice with that as you can. But I'm not going to say anything more about them. And we're going to start talking about concept of a valid argument, concept of truth as distinct from validity, and other sort of notions and arguments and this and that. So that'll be in the next episode.